I agree. That's what we need to do. So practice exam number 2. Here we go. Let's just crank through it. Wednesday's the real exam, and we're taking it the minute we walk in, right? I mean, I'll be at the door, like handing it out. All right. So, all right, number 1. Refer to the sample data for pre-employment drug screening shown below. If one of the subjects is randomly selected, what is the probability that the test result is a false positive? So, well, here, let me help you about, you don't need to write all that down. Well, do you? I was going to, I guess I better, just put this table. Can you just write that table in your notes? Or do whatever you want, but I was just trying to help you know how to write your notes. All you really need is that table and the words false positive. You don't need all those other words. If you want to write something down and not be so wordy about it all, you want to just write false positive and then that table. That's really all that matters. The rest, whatever, blah, blah, blah. False positive, that table. So can you look at that for a second? And yeah, because positive uses the drugs, does not. Yeah, it'd be the 18, huh?
How about the negative drug use, the one that uses?
You got to count for both.
Yeah.
So they're saying, what's the probability that what are they asking? If we grab somebody random, what's the chance that they got a false positive? So these 18 people are the false positive, right? Does that make sense for some? Because those 18 people got a positive test result, but really did not use the drug. So it's a false positive.
How about the 11?
The 11, yeah, what about the 11? They got a negative result, even though they really are drug users. That would be a false negative, right? Because it's negative, but it's false. They're really a drug user. And it's telling, it's a result that's negative. So that's different. That's a false negative. Make sense? False positive has got to be a positive result, but one that's not true. A false positive. So it'd be those 18. Now, it's not just 18. It's a probability. So probabilities we always divide by what? 18 over what? Total. Yeah, right. Exactly. Total. Total of all 4. We mean all of them added up. Whatever that is. 40 plus 18 plus 11 plus 33. What is that? 102. Thank you. So 18 divided by 102. Just use your calculator. Just divide 18. Whoops. 18 over 102. What are we getting? 0.1764. How many places? 3. 176. 0.176. Y'all getting that? Rounded to 3 places. Is that okay? Okay. And now, who would suffer from a false positive? Like, why would that be a bad thing? The employer would suffer. Would the employer suffer? No, yeah, Nerdin's right. The person, huh? Because it comes out positive, and they're like, no, I'm not using drugs. It comes out positive. The person tested would suffer because he or she would not be suspected? No. The person would suffer because he or she would be suspected when in reality they don't use. Yeah. Good on that. So remember, practice exam. How many do we have here? 22. There's 22 questions. I'm going to give you, I think it's only 16, 15 on the real exam. There's like 15 or 16. But it's just like these. So it's a subset of these, in other words. That makes sense? Yeah, just the 15 hardest ones. No, they're just all, I have 3 versions. They're all just mixed around. But anyway, something like that. I think there's 16. Anyway, something like that. But it's these exact ones. I mean, different numbers, but there'll be a false positive, false negative, maybe. On one of the versions. I don't even remember which one your version has. Ask if there's anything unclear. Today's our day to get it all straight. Number 2, survey consumers age 12 and older. Let me just simplify all those numbers in the paragraph. It basically says 214 said none. What is it? How many cell phone uses are in the house? 278 said 1. 366 said 2 people use cell phones in their house. 134 said 3. And 112 said 4 or more. So that's how the responses went to the survey about how many people in your household are using cell phones. I'm in the 4 or more category. All right. So then they're asking, what's the probability that if you grab somebody at random, that they'll be like I am, that there's 4 or more people in their home using cell phones. So, how do we figure that out? Let me give you just a second. How do we find probability of 4 or more?
112 divided by the rest.
Exactly. Just grab the 112 over the total, right? Probability is always over the total, huh? I don't know what the total is. Anybody got it?
1104.
1104?
Yes.
Thank you. So 112. Hey, by the way, it's a good, on the test, there's only like 15, 16 questions. You don't want to miss any. I mean, of course, that's a silly thing to say. But what I mean is, run your calculator twice. Run it twice. It's a really good idea. What I mean is, because that's a lot of numbers you're adding up, so easy to hit a wrong button, right? So what I always did, I'm obsessive compulsive, but I would add all these up, get the number, write it down, clear my screen, add them again. If I got the same answer, I'd move right along. If I got a different answer, I'd go, whoop, I hit a wrong button one of those times, and I would do it again. I didn't like nasty surprises that I made little mistakes, although it still happens to me, of course. But there's things you can do to eliminate those kind of things. I used to always ask my kids, well, I think they're still in the zone, my older 3, especially, when they take tests, especially important tests, I would always say, did you do it twice? Did you do the thing? They goes, Dad, no, I don't want to do it twice. Then they get their test back, and they have all these stupid mistakes. And I go, you added wrong there? And I'm sure they just think I'm just... But the fact is, I always get your choice. You want to make a bunch of dumb mistakes because you want to get out that door so fast. I don't want to spend another 15 minutes redoing the test. Well, you make the choices and you live with the choices. But if you'd like to get an A, you could do the test again with those 20 minutes and won't be upset about so many small mistakes. So I offer that advice to anybody. I try to do tests twice or redo. So especially the calculator, run them through twice. You get your total and that. Not good? I remember one time, one of my daughters came home from an important test, like SAT or something like that. And she found out later, she's like, yeah, after the test's over, I realized I turned the page and there were 2 pages. Like I missed, they were stuck together. And me as a dad, I'm classical dad. I'm like, really? You don't actually look? I mean, I did that. I was that compulsive. When I took those important tests, I would look, page 73, 74. I didn't miss a page. Okay, here we go. And I remember my Lizzie girl going, really, Dad? You did that? Yeah, that's what I did. I mean, you skipped a page? Are you crazy? I'm always hard on them, but that's just craziness to me. That's just nuts. Anyway, all right, so you get the flavor of how I torture my poor children. But 112 divided by 1104. You can bring habits into your life that will minimize careless mistakes. Point 101. Did you get that? At the answer? Oh, did I not make, hopefully, a little mistake there? All right. And then, is it unlikely for the household to have 4 or more? Is it unlikely? Up here they said, consider an event unlikely if it's less than 0.05. Is it less than 0.05? No, it's not. No, because the probability with 4 or more is less than. Oh, no, it's not less than. It's no, because it's greater than. So it's C. We good? All right, on we go. 3. Okay, sample space. Basically, 3 kids. You see them giving the example. Boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, etc. Yeah. All these are completely fair game. Identify. That's for 3 children. This question is asking about.
It took me so long in the homework.
Yeah. 4 children. Come on, you can do it. Let's buck up. Let's be strong. Write out a table. Pray you will not die. You can do that, right? 4 children. Crank it out.
4, 3.
Is there an easier way to do this?
Remember, we did this. I literally did this exact question.
I know, but
Yeah.
So we can use that pattern, but just add another, whatever they're asking?
You could. I don't think they're all there for that pattern.
They're not all there.
They're not all there. That's just a subset. That's just a few.
we need like a box.
You got a box.
Yeah, like Val said, just put them on your cheat sheet. Yeah, here, I can get some space. I'll help you.
1, 2, 3.
I'll help you one more time.
Let's put on cheat sheet.
All right, remember I did the tree thing? And I said, boy, girl. That's your first child. And then second, you can make them different colors if you want. Second child, boy, girl, boy, girl. And then third layer, the groans. You guys are sounding like my children now. Come on. We can do this. We will not die. A little hard work will be good for us. All right, boy, girl again on the third layer. And then the fourth layer. Again, right? We're almost there. The end is in sight. Just keeps, it gets a little messy on that last one, huh? And like Val said, you could just put this right on your 3x5 card. I don't know if there's room. This is a big one. But you could.
You put the results in the card.
Yeah, good way to put it. Just do the results, yeah. So there's the fourth layer, fourth child, right? So the red is your first child. You have a boy or a girl, and then boy, girl, boy, blah, blah, blah. Just keep going. And then we got to put the endings. That's what Val means. Remember the endings? Like, what does this all equal? If, in other words, you start here, your first child was a boy, then you had a boy, then you had a boy, then you had a boy. You had boy, 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 boy. Or what about this ending? Next ending, you had boy, 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 girl. Boy, 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 girl. Yeah, so, and we'll just keep going. Maybe I'll just keep going. All right. This just gets kind of messy. I'm going to change colors or something. So, boy, boy, what is it? Girl, boy, and boy, boy, girl, girl. And then boy. I'm just following the tree. See how I'm just following the tree through there? So boy, where is I'm getting lost. Boy, girl, boy, boy. How do I get there? There we go. Boy, girl, boy, boy. And boy, girl, boy, girl. Whew. And then this one, boy, girl, girl, boy. Yeah, you don't want to be doing this on a test, huh?
No.
Just have this ready ahead of time.
That's the whole hour.
Yeah, right. All right, and the next one. Now, if it helps at all, we're at the halfway point. This is half the tree. See that? The next half is going to be identical, except it's all going to begin with G, because it started with a girl. And then all the rest are the same last three. You know what I mean? Just take everything you have at the top and start with a G instead of a B. G, boy, boy, boy. And G, boy, boy, girl. And G, whatever, boy, girl, boy. And G, boy, girl, girl. Yeah, just keep going. I'm going to change colors here. And another G, whatever. I'm breaking into fourths here. Girl, boy, boy. And girl, girl, boy, girl. And girl, 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 boy. And girl, 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 girl. 4 sweet girls. There we go. All right. So what you could put on your 3x5 card or your 4x6 card would be this. This is what. Just put that right there on your card. That's all we really need is the endings, huh? All the different results of having 4 children. Yeah, it'll be on YouTube also, but feel free to take a picture. All right, so so now what's their question? So how many different endings are there? 4, 4, 4, 4, right? 16, right? There's 4 here, 4 here, 4 here, 4 there. 16 different ways the family can go as far as gender for the 4 children. Let's go back, and then what's their question? Oh, I've lost their question. Honestly, remember the test is multiple choice. I'm not going to have you list anything. I'm going to just ask you, really. So that's what they want here, though. Yeah, that is what they want right there on the practice exam. Yes, on the practice exam, you do have to list all of that with commas. Does that make sense? So now you got to go B, 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 comma, B, 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 G, comma, and on you go. Yeah, you do. So all that. But I'm not going to ask you to do that on the exam. You're just going to do multiple choice. I would just ask you this question. Find the probability of getting 3 girls and 1 boy in any order. 3 girls and 1 boy in any order. So 3 girls, 1 boy, any order. So that's what I'm going to ask you on the exam. We already know the denominator is 16, right? Because the total number of possibilities is 16. That's always the bottom of probability, huh? Let's go back and see how many, what was it, 3 boys, 1 girl? Where is it? There it is. So this is what you have to type in for the practice exam. All those separated by commas. But now, I'm not going to give you that in the real exam. I'm just going to say, hey, what's the probability? 3 boys and 1 girl. So how many of those 16 are 3 boys and 1 girl?
1.
Think about it this way. I mean, you can look and everything, but let me help you so you don't miss one. If I said, hey, I had a family with 3 boys and 1 girl. How many different ways are there to do 3 boys and 1 girl? Focus on the 1 girl. Yeah, how many are there? How do you know right away it's 4? Yeah, where could the girl be? There's only 1 girl. Where could she be? First, second, third, or fourth. With boys everywhere else, right? It's got to be, right? So there's the girl last. There's the girl third. There's the girl second. And where's the girl first? There. There's the girl first. With boys in all the other slots. Sure enough. 4, huh? 4 different ways to have that happen. Does that make sense? Yeah. So it's going to be 4 over 16.25. Exactly. Come on back. Yeah, so 4 over 16.25 is the chance of that. On that. So there we go. All right, so I'm going to move on from that one. If you're good, are we good? Questions? All right, number 4. Another table. Drive-through restaurant. Use the data. Which lists drive-through order accuracy? Hot fast food, blah, 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 blah. If one order is selected, find the probability in order from restaurant B. So this is all we need here. From B or C or not accurate. So really, all you need is put that table in your notes, and then just write B or C or not accurate. That's all you need. You don't need the rest of those words. Just that table, B or C or not accurate.
So would you add all 3 of those together divided by the whole?
Yeah, there's a few different ways you could do it. So basically we want all the B's, all the C's, and all the not accurates over the total, huh? Anybody add up the total?
Yes, 1,143.
1143?
Yeah, 1143.
Seems like it's always 1100 something, huh? Okay, 1143. Good. Yeah, so you get the total for sure. Okay, now what's going to go on the top? Let me give a little more room here. Wait. So total on the bottom, which is 1143. And we want to get all the A's, all the B's, and all the not accurates, right? On the top, A's, B's, and not accurates. You tracking with me? Now watch. This confuses a lot of people. This isn't easy. Let's go through and be as real as we can with these numbers. Oh, not A's and B's, B's and C's, huh?
Yeah.
Just let me know when I do something crazy. B, C. B's, C's, and not accurates, huh? Okay. So what are all the orders from restaurant B? Well, it's both those, huh? Wouldn't you agree? Those are all from restaurant B. Right? Everybody understand the difference? The 269 were from restaurant B accurate, and the 54 were from restaurant B not accurate. Whatever, we need them all from restaurant B. They said all of them from restaurant B, all of them from restaurant C. So all of these are from restaurant C. We need to add those in the top also, right? Good so far? Or not accurate. Are there any other not accurate orders? The 40 and the 20. We have to add up all those. Basically everything but the upper left and upper right, huh? Do you see how I did that? See how that's B, C, and then these are the other not accurates. Is that making sense? You okay on that? So make sure that really makes sense, because it'll be like this on the thing, but they'll change the particulars. They might say, A or accurate or something. Yeah.
All of B.
Yeah. So I did all of B, all of C, and I had to get all the not accurate also. So I hadn't yet got the 40 and the 20.
Just those other things.
Yeah. Now another way you could have, let me say it another way so you really get it. You could have said, I'm going to start with the not accurate. That's fine. The whole bottom row. Right? You could just start with the whole bottom row because all those are not accurate. And then, and I make sure I get all B and all C. Then you would just circle the extra top two on B and C because you'd have to have all B and C in the end also. However you do it, when all is said and done, you're going to have all B and all C and all the not accurate.
And divide that by the whole total.
And divide that by the total.
Like everything.
Everything. Yeah, which is the 1143. People told me, right? Does that make sense on that? So on the real test, it'll be just like this. Then they'll say something like A or accurate. Then you would say, okay, all of A, and then all the accurate, the top row, for example. You get it? Get how that would work? So whatever they say, you just got to add all those up over the total. What? Somebody got the top number?
581.
581. Anybody else getting that same number? Want to try? Yeah, you got it too?
581?
Oh no, I mean that's the final answer, huh? What's the
664.
Oh, okay, 664.
4 divided by 1143.
And then it comes out 0.581, you all saying?
Yeah, 4.580.
Better rounds. Okay, did I say 3? Yeah, 3 places, huh? Good. You feel okay about that? If there's an or question? Good, all right. On we go. Number 5. I want to make sure I get through them all here. Okay. Use the following results from a test for marijuana use, which is provided by a certain drug testing company. Among 150 subjects with positive test results, there are 26 false positive results. Among 153 negative results, there are 5 false negative results. If one of the test subjects is randomly selected, find the probability the subject tested negative or did not use marijuana. This is a hard question. Hint, construct a table. Yeah, so there's on one of the versions, I don't remember if it's yours, on one of the test versions, there is a construct a table one. So this is just like the last one, but harder because we have to make our own table. Otherwise, it's just like the last one, but you got to make your own table. So can we do that? Let me give you a second. Think. All right, here we go. So these drug ones, you always do positive, negative, and use or don't use the marijuana, right? That's always how these drug ones are. Positive, negative, use or don't use. So then you just stick the numbers in the boxes.
Well, don't we subtract? I feel like
we might have to sometimes, yeah. I don't know. I'm just going to go through it and see. I have no game plan. Let's see. 150 subjects with positive. Yes, let me help you go through this. So everybody good with that table idea? Yeah. Right? And then we're going to have totals, you realize, outside that. Over here is going to be total. And over down here is going to be total. Okay? Everybody got their table set up like I do? Mm-hmm. Now, what do you do with this 150 subjects with positive test results? That's the total positive. Do you realize that?
Yeah.
That's the total number of people who tested positive, right? Among 150 subjects with a positive test result. That's 150 with a positive test result. Yeah, and then they say among them, 26 were false positives. So where does that go? Exactly. 26 don't use. They were false positives, right? They're in the they tested positive. They're in the positive category, but they don't use. They're false positive. That's what they're telling us, huh? And then how can we get the other one? Yeah, by subtraction, huh? Right, we're going to subtract to get the other. Right? 26, if this totals 150, just subtract the 26, we'll get the other number. Everybody see how I'm doing it? This is one of the hardest ones we've had so far. So this will be 150 minus 26, which is, what is it? 124. We good so far? Is that making sense? Positive and users. And then we go on to the negative. So can you do the same thing for the negative? Let me let you do that rather than me just whip it out. Try the same thing for the negative. So 153 negative. And 5 are false negative. So they go up there, huh? Yeah, good. Everybody see, because they tested negative, but they're false, so they really are users. But they had a negative test, so they're false negative. They really are users. Their negative result was false. Is that good? Does everybody see how I know where that goes? Then you just subtract to get the other one, huh? Yeah. So right there, 153 minus 5. So 148. And, okay, good. Now, are we ready for their question? What is their question? The probability that a randomly selected subject tested negative or did not use. Tested negative or did not use. Tested negative or did not use. Let me give you just a second. I think you'll get different ways. You could say tested negative. So these are all those people, or you can just take the 153. Those are all the negative, right? So you need the 153 for sure. Plus, that's all the negative testing people, huh? Plus the 26. Beautiful. Did not use. Plus the 26. Exactly. Does that make sense? That good? Yeah. Over whatever the total is. And the total means, it's 303. I can tell because it's these two total up. It's got to be 303. 150, 150, 300, 303. So it's 153 plus 26 over 303. Whatever that is, 179 over 303. I'm getting 0.591. 3 places, yeah, 0.591. So that was that was the same as the last one, but we had to make our own table, so it's a little bit harder that way. So you can put that right in your 3x5, 4x6 card, if you want. No, there's just so much you can fit on there, though. Questions on that one before we move on? All right, I better move. I want to get through them for you. But this will be on YouTube. Feel free to go back and look at it. So, among 7670 cases, 7,670 cases, a heart pacemaker malfunction, 358 were found to be caused by firmware, which is software programmed into the device. If the firmware is tested in 3 different pacemakers, randomly selected from the batch of 7, so the entire batch, except if there's no failures, what's probably the firmware of the entire batch will be accepted? Yeah, these are all former homework problems. Remember, this is a hard one. So basically, they're saying so we have 7670 total cases. That's like the total. And how many are? What does it say? 358. 358 are basically bad, right? Bad firmware. So that's what's really out there in the batch of all of them. Makes sense? There's 70 total cases. 358 are bad. It's bad firmware is what it really is. These are all ones that failed. These are all 7 cases, but 358 were bad firmware. So anyway, if the firmware is tested, so what do? They test 3 firmwares. They test 3 firmwares. If all 3 good, they accept the whole batch. That's what it says, right? The entire batch is accepted if there's no failures from 3. So basically, that's their game plan. That's their quality control. Companies have this, and it's all based on probability. It's all based on statistics, whether it's a good plan or not. So this is their plan. Is it a good plan or not? They say, here's what we're going to do. We're going to test in every batch. We're going to test 3 at random, pull them out, because we don't have time to test them all. We're just going to grab 3 firmwares. If they're all good, then we're going to let the whole batch go on. If any one of them's bad, we're going to yank the batch. So what's the chance? Is this procedure likely to result in the probability that the entire batch is accepted? That's what they're asking. The probability that they'll accept the whole batch. So that's the question. What's the probability that's going to happen? You don't want to do that, right? That would be a bad thing, because you know there's a bunch of bad ones in there. There's 358 bad ones. So we're kind of saying, is this a good quality control plan for the company? Or should they change it? So now, what's the chance if they do it this way, if they just grab 3 at random, look at them, all 3 are going to be good, and they're going to pass it right on? That's what we're figuring out here, right? What's the chance they're going to find 3 good ones in a row? Because that's what means they'll accept the whole batch. So what's the chance you're going to find 3 good ones in a row? What's the chance of getting 1 good one? Let's start there. What's the chance if you reach into that 7,670 cases and you grab one out and you look at it, it's going to be good firmware?
1 out of 76, 7?
Is it 1? Is there only 1 good one? Out of 76, 70?
We get subtract the bad firmware from the total, and then that's what you go based on?
Yeah. See what Nuruddin's saying there? Right, we got it. The probability of grabbing a good one is how many good over the total. Does that make sense? How many good are there? Well, there's 358 bad ones. 7670 total, right? This is the total. So if you take the total, 7670, minus the 358, that's going to be how many good ones. Let's just do it over here, right here. So the number of good is going to be the total minus the bad. 358. Somebody got a number there? What is it? 7,000? 312? 7312 good ones. See how we came up with that? 7312 good ones. Okay. So then, so the chance you're going to get a good one is 7312 out of 7670. The total is on the bottom, of course. That's how many good out of total. It's likely. It's likely. Most of them are good, right? Makes sense that that's a fraction close to 1. Most of them are good. But we don't just want 1 good one. What do we want? 3 good in a row. Good, good, good. If so, the whole batch is approved, right? So what's the chance that you're going to get 3 good ones in a row? What do we do? Anybody know? Cube it. You multiply it by itself 3 times. Yeah. Yeah, what they're testing here is the difference between and or. That was what this probability section was about. We just did a bunch of or questions, right? They said this, or this, or this, and we would add those up. This is an and question. Do you see the difference? We're trying to grab a good one, and another good one, and another good one. 3 goods in a row, aren't we? That's what we're talking about. This is an and question. For and, you multiply and not add. So you're going to multiply this by itself, which is just third power would be easier way to do it. Let me slow down. I'll say 2 things here. So first off, you're going to multiply this thing by itself 3 times because and means multiply. Are you catching the big idea? Yeah. So on the test you take Wednesday, there's going to be, well, there might not be, but on the different versions, there's some and some or. You might just get one of those, I don't even know. But you could get them both. There might be an and, there might be an or, there might be both. So if you get an or question, that's add them up, where we just did a bunch of or ones, drug, they're a user, or they're positive, or that other restaurant A or B, or not accurate. We added all those up, right? But and, you don't add them up, you times them. See the difference? You times them. And you times. So I multiply good and good and good, right? See that this is an and question? I don't want to get the first good or the second good or the third good. I want to get the first good and the second good and the third good, all three good, so that we accept the whole batch. I don't want just one of them to be good. If only one of them is good, we're not accepting the batch. I want to get all three good. Yeah.
So if they wanted to find like 5 in a row, what do you do?
5 of those. Yeah, and what's the easy way to multiply the same thing by itself 3 times? Yeah, just to save work, just take 7312 over 7670 to the third power on your calculator. That means 3 of those multiplied together. Yeah, so if they had 5 in a row, then you just go 5th power.
What button do we push?
So the up arrow is your power button. Yeah. So the up arrow 3. So type that fraction, but you got to have hit equals beforehand, so it doesn't just do the last number. Am I making any sense? So here, I'm kind of running out of room.
So you do the 7312 divided by 7670 equal, and then.
Yeah, perfect. Yeah, let me write it out exactly. So do the 7312 divided by the 7670. Yeah, then hit equals, so you get the answer before you do the third power. Everybody tracking with me? Here's what you want to type, and then one more equals at the end. You have to, the reason you have to hit equals here before you do the third power, if you don't, it'll only raise the last number to the third power rather than the whole fraction. Here we go. Is that making sense? So 7312 divided by 7670 equals, that gives that whole decimal thing. You get a decimal then, right? And then to the power of third equals. And you'll get your answer. Somebody got it? Nobody get it? 7312 divided by 7670 to the third. Yeah, 0.866? 0.866. That's the chance they're going to accept that whole batch. Is that a good idea? That's a terrible plan, right? There's an 86% chance they're going to let that batch get through that's got 358 bad pieces in it. That's not a good plan. Does that make sense? So the procedure is likely to result in the entire batch being accepted, right? That's likely, isn't it? Now, how would they fix something like that? Well, they would check like 10 in a row or 20 in a row. Real quick, go back with this, and if you raise this to like the 20th power, what if you raise that to the 20th power? So 7312 divided by 7670 equals to the 20th power. Well, now I still got like what, a 38% chance? Much lower though. The chance you're going to get 20 good ones in a row is lower. It's still not where you'd want it. But anyway, that makes sense on that? You okay? So if there's an and question on the test, you multiply. For something to happen, this and this and this, you multiply those. Or questions we add. So let me write that somewhere. And means multiply. Or means add for probability. So if you want restaurant A or restaurant B, you add them up.
And you must press equals before you put
you got to press that equals. Yeah. One good thing, because I could try to throw out these little rules, but better is if I give you a feel of what the calculator's doing. When you're watching that screen, if you didn't press that equals, if you just did 7312 divided by 7670, and you're about to go up arrow 3, look at what's on your screen at that moment. 7670 is on your screen. So if you do up arrow 3, it's doing that on the 7670, which you know is not right, because you're supposed to do the whole fraction to the third power. You know what I mean? That's how to just know. Then you hit equals, and you get the decimal. It's good to watch your screen as you're typing these things in, so you know what the calculator's doing, and you got your fingers on the pulse of the calculator, so to speak. You know what it's doing. Does that make sense? When you hit equals, then you saw that decimal all of a sudden, huh? And then oh yeah, that's what I want. I want the decimal. The whole fraction is a decimal to the third power. All right. So maybe I beat that one to death. Let's just keep going here. So groups of adults. All right, we're changing gears. That's it for probability. Groups of adults are randomly selected, arranged in groups of 3. Blah, 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 blah. Whatever. It's something about comfortable with self-driving vehicle. You might remember this one. So in the end, is this a probability distribution? Yeah, it's got different, this is if you grab 3 adults, how many would be comfortable with a self-driving vehicle? Would you get in a self-driving vehicle? They have those trucks already that go across the nation, right? You just have a person sitting in there that drives itself across the nation. No. Yeah, I think so. That's supposedly the future. We'll see. Anyway, what's the chance? Out of 3 people, what's the chance that none of the 3 would be comfortable? 35% chance. 1 out of 3, 2 out of 3, 3 out of 3. That's what that is represented. How many people out of 3 are comfortable being in a self-driving vehicle? All right. Does the table show the probability distribution? Yeah, it does. Yeah. So let's go on to the next question. So yes. Okay, now, find the mean. Do you remember? I'm a little rusty with you. I had to look it up a couple hours ago. I had to remind myself. It's calculator. It's the binomial distribution. So let's do this. So this is what you might want to put in your 3x5 card. So this one. So a lot of the battle is going to be recognition. Not binomial. I'm sorry. I'm not saying the right thing. It's a probability distribution. Yeah. So we're going to go into stats. Yeah, so a lot of the battle on the test Wednesday, I think you know how to do all these things. The battle is knowing which thing to do when, huh? Yeah. Like recognition, you know what I mean? Looking at that and going, oh, that's this type, it's not that other type. So I want to try to help you with that. That's a lot of what you want to do today and for yourself tomorrow as you get ready for the test. When you see this, do you see you're going to put this in L1 and that in L2. So go to your stat mode and put in the first list in L1, the second list in L2. Put them side by side. Remember how to do that? Just go stat, edit. No, none of that yet. We're not going to use any of that. Just hit the stat button. Just hit the stat button and get your L1, your L2. Remember those? And just put 0, 1, 2, 3 down L1. Put those probabilities down L2. And then when you're done, you hit stat again. Go over to calculate. See if I can find it. Over to calculate. Hit enter. And then before you hit the rest, you got to put L1, L2, enter. And then it gives you the numbers. And it tells you X bar is, 0.867. 0.867. And the next question, standard deviation, that's the 0.783. I'm looking at it, right? Yeah, 0.783. So let me help you. The squiggle thing, it's, yeah. Some of you guys have the ones. What does it say? It says, what's the first entry say?
List. L1,
yeah.
Frequent list, L2. The second one's L2.
List and then frequency list or something?
Yeah, frequent list.
Yeah, so you just put L1 here, L2 there. And it's all good. You don't have to do a comma. So if your calculator shows that, I'll say or. If your calculator shows that, you just put L1 the first spot, L2 in the second, hit enter, and it'll. All right, I'm going to move on. We're good. We're all good? All right. Next one, probability. Okay, so basically I'm going to jump to the question. The probability of exactly 4 sleepwalkers among 5 adults. So sleepwalkers. So let's come on down. So here's the probability table.
0.024.
Yeah, so what's the chance of, let's go back in. Exactly 4. Yeah, exactly 4. 0.026. That's probably out of 5 people, you'll find exactly 4 sleepwalkers. Any sleepwalkers in here? My family's loaded with them because my wife is. My wife was. I guess she's aged out of it. But when we first married, she'd wake up in the middle of the night, usually laughing. She'd just wake up, ha, 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 say 3 or 4 phrases, sometimes walk around the house, back to bed. I'm like, that's just weird. And guess what? My kiddos, same thing, walking around the house. So literally this weekend, we took this trip to Humboldt. I got all the kids together. Emma came home from Cal Poly. We had a nephew getting married up in Humboldt. So we all piled in the van, went all the way up there with everybody. And so my 23-year-old had to share a bed with my 15-year-old boy. The 2 boys were in one bed, my wife and I another, and the other kids were in another room. Anyway, my 15-year-old's still in the zone. He's the only one left still in the zone. Middle of the night, and we're all in the hotel room. He says, and I guess he started grabbing my 23-year-old boy next to him, shaking him and doing different stuff. Daniel's like, leave me alone. And then I'm like, and in the morning, we're like, John, do you remember that? No, I just went to bed and slept. Anyway, so we got it going on. So sleepwalkers. So 4 or more sleepwalkers among 5. 4 or more among 5. What do we do?
Add 4 and 5.
Yeah, just add them up, right? 0.006, just add them up. So 12, we add that up. 6 and 6, 12. Use your calculator. 0.032. 0.032. Okay, question C. Which probability is relevant for determining whether 4 is a significantly high number? Well, whenever you want significantly high, you want 4 or more. You're not saying 4 exactly. You want 4 or more. 0.032, that one. Since probability getting 5, 4 in the result, since probability getting fewer, what? I don't even know what answer it is. Since probably getting 5 sleepwalkers includes getting 4 sleepwalkers. Okay, yeah, I guess that's it. I'm not going to put that question on the exam, to tell you the truth. That's kind of a weird question. A or B, though. I would give you A or B. And then D, is 4 a significantly high number? Is this significantly high? Remember, significant if it's under 0.05. That's what we always mean by significant. Is that under 0.05? Yeah, it is, huh? 0.03, 3% is under 5%, huh? So, yeah. So, like in my family, bunch of sleepwalkers. So, it's obviously no luck. It's from my wife's genes. So, yeah. So, does that make sense?
So, yes.
It'd be yes. That is a significantly... I know it's kind of... You make it says high number. Yeah, they mean 4 or 5 is a high number of... if you just grab 5 people at random, you grab the Heron family, you grab 5 people at random, you're going to get a bunch of sleepwalkers. And that can't be luck, they're saying. There's a low chance to get that many sleepwalkers out of 5 people, 4 or more. What's that? Is it 8? Yes, it is less than... Yeah. It is A. Thanks, Ken. Yeah, it is A. We good there? Make sense? All right, on we go. Okay, so what number is this one? Number 9. In the States, how we doing? 35 minutes. Okay. In the States, pick 3 lottery game. $1.32. You pay $1.32 to play. 3 digits. Da-da-da. Select the state with da-da-da-da. All right. How many different selection processes? So you're playing this game where you got 3 digits. Like 233 or 577 or 091 or 004 or whatever. And so how many different ones are there? Yeah, 1,000, right? We good with that? Because it's 000, 001, 002, all the way to 999. And from 1 to 999 is 999, and then throw in this one, there's 1,000 different combinations, aren't there? Does that make sense? 1,000 different combos. So 1,000 selections are possible. What's the probability of winning then? 1 in 1,000, yeah. It's 1 in 1,000, which comes out 0.001. Like that. If you win, what is your net profit?
3.78 minus 132.
Yeah. Yeah, if you win, you win $493.78 minus the fact that you had to pay $1.32 to buy the ticket. So what is that? 49246. 49246. That's how much you would win. Find the expected value. So there very likely could be an expected value question on the exam. It's on some of the versions for sure. How do you do that? How do you do expected value? Well, what you do is you do what we just did with the L1, L2, and you just put the different monies. So what you could make 492.46, right? Or what else could happen? You're either going to win and you're going to win 492.46, or you're going to lose, and if you lose, how much money do you lose? $1.32. So that's a negative because it's a loss. And this one's a positive because it's a win. And over here you put the probabilities. What's the chance you're going to win? 0.001. That's what we did right here, right? Chance of winning. So what's the chance you're going to lose? 999. Does that make sense how I came up with those? Right? So, and when do you do this? So this would be a good thing to write on your 3x5 card. For expected value, if you see the words on the exam, and it's certainly on some of the versions, expected value, you should write yourself a note that says, make the L1, L2 list, just like that, and then hit Stat, move over to Calculate, hit Enter, do the L1, comma L2, enter, or however you put in L, just what we just did last time, and look for the X bar. The X bar, the average, that's what expected value is. It's the average amount of money you expect to win or lose playing this game. Don't forget the negative. And remember how the negative is different than the subtraction button? Remember, you got to use the negative in the lower right-hand corner with the parentheses around it. Remember, the TI gets really upset. I wish they would make it a little more user-friendly. But it gets really upset if you use the subtraction instead of the negative. So put that in. The X bar will be the answer. I'm going to do it too. I'm getting negative 0.826. All right, let me help. This, let me write a little bit more what it is I'm doing. This is the chance of winning, huh? And this is the chance of losing. Right over here we said, what's the probability of winning? 0.001, 1 in 1,000. And so the chance of losing is 1 minus the chance of winning, right? It's like rain or no rain, win or lose, right? You just got to take 1 minus. So the chance of losing is 1 minus 0.001, which is 0.999. That's how I got this right here. Right? So if you win $492.46. The chance of that is 0.001. If you lose $1.32, the price of your ticket. The chance of that is very likely 0.999. See what I'm doing there? I'm putting in the amount we win or lose and the chance of it. The amount we win or lose and the chance of it. And then you just let your calculator do the work. And the average, that's what an expected value is. That's what the casinos do. They know the average amount of money a person's going to lose every time they roll the dice or do whatever. Make sense? That's what that number means. On average, you're going to lose 83 cents every time you play this game. Even though you can't exactly lose 83 cents, that'll be the average after you do it thousands and thousands of times. What that means. Is that good? Are we okay with that? Feel like you could do that on the test? Yeah. Oh, did I round it? Yeah, I should have went minus 0.83. Huh? I should have rounded to the hundreds. Yeah, this is the hundredths place, right? 2 zeros, 2 places. Thank you. Negative 0.83. Yeah, and then this one says, which is better? Well, they gave the same thing here, didn't they? So neither's better. They made up some other game, but it ended up having the same expected value in the end. So neither is better. They are the same. All right, I better move on. There's times to run, there's hard ones. Number 10. Adults use smartphones. 46% use them in meetings or classes. If 9 adult smartphone users are randomly selected, find the probability that exactly 4 use their smartphone in meetings or classes. Okay, now this one seems different, huh? There's no table given to us. So I'm trying to help you see the marks that you can recognize on the test on Wednesday. So it seems like the last questions we've been doing, notice the question is exactly 4, but there's no table provided for us. If there was a table, you know what I mean? Like the last one said, we had the table. We just said exactly 4, 0.026, and that was great. But there's no table here on number 10. How do you do the exactly 4, or the next one's going to say at least 2, and on you go, when there's no table given to you? Binomial. Yeah, so remember, this is going to be the kind. So let me write a note to help you recognize when there's no table given, if they say exactly, you use binom PDF, right? Yeah, binom PDF, and when they say greater, or let's say less, well, we'll get to that in a minute. How about that'll be the next question. Let's wait. Binom PDF, and you're going to do number of trials, the probability, and then the exact number, that you want. Sorry, I'm running out of room there. Probability and the exact number. Does that make sense? That's what you put. So you want to go to your distributions now. So you're going to do binom PDF. It's on you. It's under second vars, right? Variables. Second vars. It's one of the distributions. Binom PDF. What's the number of trials here? How many people are we?
9.
Yeah, 9. 9 adult. You're grabbing 9 people at random. 9 is the number you're asking or surveying or whatever. 9 people, and what's the probability for each one? 46%, right? So 0.46. And what's the exact number that you want? 4. We want exactly 4. So put that into your calculator. I know, whatever they say. Yeah, 4 decimal. Whoops, I did the wrong thing. Binom's way down at the bottom, huh?
Yeah.
9, 0.46, 4. I'm getting 0.2590 on the exam. They're saying like exactly, greater, less, whatever, and there's no table given, huh? So then you go, oh, yeah, so it's the binom. And also, binomial comes from 2 states, like bicycle, 2 states, right? They either use the cell phones or they don't. There's just like 2 states there, right? Use the cell phones or don't. Okay, number 5, number 11, super similar. This time, at least 2. So, okay, so what do we do for this? Let me give you the game plan. If they say less, well, if they say less than, or let me just write it. If they say equal, we just did that. You do binom PDF. That's one we just did. If they say less than or equal, you do binom CDF. And if they say, what do they say? Greater than or equal, then you've got to do what? You've got to do binom CDF, and you've got to go number of trials, and then 1 minus, wait, I'm getting confused. You got to do the probability and the number, the exact number that they gave you. I don't know how else to say that. It's called the X, the exact X number. And then you've got to take that answer that's greater than that. You got to subtract. You got to take this answer. Then you've got to go 1 minus answer. Wait, is that right?
Yep.
At least 2. That's less than or equal. That's 2 or less. At least 2. Yeah, no. There's a small mistake there. How do I say it in the easiest way? What did I write before? I wrote. I mean, I know how to do the problem. I just don't know how to make it seem easy.
You close, you subtract by 1.
Um,
From the answer.
yeah, but we're subtracting the wrong thing though.
There you go.
Do you got what I wrote? What did I write? You're a good note taker, Mike. Binomial then 1 less answer. Oh, did I write that?
I wrote that too.
That's not quite exactly right. Unless I'm spacing out.
You're spacing out because
They're saying at least 2. You're talking to 7 people,
You gotta put 1.
and you want at least 2 of them to whatever. So what does that mean? If I talk to 7 people and at least 2 whatever, at least 2 means 2 or 3 or 4 all the way up to 7, right? At least 2 means 2 or more. What's the opposite of that then? The opposite of 2 or more is what? 0 or 1. Right? 0 or 1 out of the 7 people do the whatever with their phone or whatever. Right? So always think about what the opposite is. Because why? Because this binomial CDF thing only does less than or equal to at least directly. Yeah. So, what am I saying? Yeah, okay. Let me try to say it as clean as I can. Of course, I tried that before and blew it. Okay. So so those instructions I wrote out for you are not quite exactly right. Those ones I wrote previously. I apologize. So if they say, one more time, if they say less than or equal to, that part was good. You just do binom, CDF, that's all good. Number of trials, and probability, and then the X, whatever the X is. Okay. But if they say greater than or equal to, right? Let me come down here and write it out for you. I don't know why I was just not thinking well that day, I guess. If they say greater than, like more, or they say greater than or equal to, which would be at least, or some phrase like that. If they say something like that, you must change to less than or equal to. Less than or equal to. Why? Because that's because that's the only way that this binomial thing can handle it. It assumes what you put in there is a less than or equal to number. So that's why I looked at this at least 2, and I thought, okay, at least 2. What does that mean? 2, 3, 4, I need to change that to be the opposite. What's the opposite of 2 or more? I thought 0 or 1, which is what? Less than or equal to 1. Right? So that's what you have to do. You have to change it because what you put in here the calculator automatically assumes you mean there or less than or equal to that spot. So you've got to do the opposite. So the 1 minus part is true. I mean, that's true. How did I write? I said 1 minus the answer. It's just, yeah. Sorry, I'm not making this very simple, am I? I don't know how to say it really, really simply very well.
Can you write out the actual?
Yeah, here, let me, what number was this?
11.
Number 11. So one more time, and then I'll move forward. Yeah, I'm running out of time here. So again, if they say equal to, you do binom PDF. If they say less than or equal to, that's simple. Binom CDF, number of trials, probability X. And then what if they say, here, if they say greater than a number, here's what you do. I guess I could write out exact things. Binom CDF, number of trials, probability, and what you put here is, so greater than 7. So yeah, that'll work. And then you take answer 1 minus answer. So now you're probably saying that's exactly what you did before, right? Mm-hmm. It is, but notice it's for greater, not greater than or equal. That matters. Versus if they say greater or equal, so these distinctions all matter. It's very, very tight. It's greater than or equal to, then you got to do binom CDF, number of trials, probability, and no. Greater than or equal to 7. X minus 1. And 1 minus the answer. Yeah, that'll work.
That's what you put on the notes for like the beginning of the week or like the beginning of the lesson. Same thing.
Well, what I put is greater than or equal to there. There's a distinction between greater than and greater than or equal to. So this would be like if they said more. More. This would be if they said like at least. Do you see the difference? Slight difference. X minus 1. If they say greater, you got to do X. If they say greater than or equal to, you got to do X minus 1 there. Now, yeah.
So, whenever we see the at least, it's going to be always 1 minus the answer. Because I never, that's all we pretty much see, or at least I see in the homework grade.
Is it least?
I only see at least, fewer than, or exactly, or
okay. But we do have higher goals than just the test. I mean, I know the test is on our mind. But you're taking these because you want to learn to think reasonably about statements like this, right? So, I mean, I sort of don't like writing this. It's just the test. That's not really, it's better if you can really just grab it, like I was saying, logically.
Can we do the problem?
Yeah. So let's finish up this problem. So the best thing to know. So if you really understand it, you don't need all these little rules. You get it. In other words, so the main point. Let me try to give it to you that way. When you use binom CDF, this first part is number of trials. Second part is probability. This third part, it always does less than or equal to automatically. So therefore, we have to work with it when they give us a question other than less than or equal to. We have to fit it to do that. Do you know what I mean? So if somebody, so you have to, so let me write, you must change whatever question they give you to less than or equal to form. So, what if somebody says to you, let's practice this. What if somebody says to you, out of 7 people surveyed, what's the chance more than 3, whatever. More than 3 use their cell phones or whatever. More than 3. Change that. Give me the opposite. Give me the opposite. What's the opposite of more than 3?
2.
First off, let's be really clear. Out of 7, what is more than 3? More than 3 is like 4, 5, 6, or 7, right? Out of 7 people, if more than 3 do whatever, then that's 4, 5, 6, or 7. Isn't that more than 3?
Yeah.
Okay, and what's the opposite of 4, 5, 6, or 7? 0, 1, 2, and 3. Right? And so what am I going to stick in my binom CDF? Whoops. In the binom thing, binom, you have to put this number here, has to be less than, what, that's less than or equal to what? Less than or equal to 3, isn't it? Isn't 0, 1, 2, and 3 less than or equal to 3?
I'm lost.
So what number do you put in there?
First one.
So you put in the 3.
That should be a problem.
If somebody asks you more than 3, you do less than or equal to 3 and then do 1 minus the answer because it's the opposite of that. No. You put 3 in the binom thing, it gives you a decimal, and then you take 1 minus that decimal answer. Is that making sense? You do binom, you do the binom of 3 and take 1 minus the answer.
That's the same thing as the other example.
Same thing as which example, Ken? Well, let's check. The one we're looking at is not more, it's at least.
Yeah.
So what if they say at least 3?
So it's 7.47.
Wait, hold on. Let's take it a little slower.
Yeah,
Just
but this
real
is
life.
confusing me now.
What is at least 3? Just real life. Just cut everything out. If I said, hey, there were 7 people, and at least 3, whatever.
So 3, 4, 5, 6.
At least 3 means 3, 4, 5, 6, or 7, huh?
You'll plug in 3.
It includes the 3, right?
Yeah.
At least 3 includes the 3, whereas more than 3 does not. See the difference?
Yeah, before.
So then the opposite, what's the opposite of 3, 4, 5, 6, or 7?
1, 2, 0, 1, 2.
0, 1, and 2. Different than that, huh? You tracking with me?
Easier to do the problem.
Yeah, killing us.
Let's do the problems.
All right, so at least 3, right? Doesn't it at least 3? You know, if I said, hey, there's 7 people over, yeah, there are. The front 2 rows, if I said, hey, I talked to them all before class, and at least 3 spent $100 on their calculators. That'd be crazy. What if out of these 7 people, I said, hey, at least 3 of these people told me before class they spent $100 on their calculator. At least 3.
3 of them did.
At least 3? Doesn't mean exactly 3.
3, 4, 5, 6, 7.
At least 3. So you really, you want to understand that phrase. That's important to your ability to communicate quantitatively out in the business world. At least 3. What does that mean? At least 3.
3, 4, 5, 6.
3, 4, 5, 6, or 7. At least 3 means 3 or more, doesn't it? And so what's the opposite of that? 0, 1, or 2. Isn't that the opposite of 3 or more? 0, 1, or 2. Okay. And so what is that for the binom? Remember, the binom function on your calculator, the binom CDF, only does less than or equal to. That's all he can do. So 0, 1, 2 is less than or equal to what number?
So you'll put 2.
2, huh? See how it comes out different?
Just like on the other problem, you'll put 1 instead of 2. Because it's at least 2. Right?
1 or less.
I don't. Grab me after if you want to. I'd rather than, I don't know what example you mean and might get confused. Everybody good on this one.
The original problem on 11. It's 7.47 at least 2.
Is it at least 2?
Yeah.
So we put
So
1.
you put 1. That's what I'm asking. Instead of point, you just put 1 instead of 2.
Yeah.
Right.
So it'd be easier for us to understand if we did the problem.
Yeah. No, I'm going to get back there. Okay. So are we good? Are we good to hear? Is this making sense?
Yeah.
All right. And so what would you do? You would do 1 minus answer, putting in the 2. Because that's the opposite, right? They actually want at least 3. All right. So back to the problem. So let's go back to the problem. Number 11. Back to the problem. Ken, grab me after if you want to talk about this kind of thing. Let's take a look at this. So, trials, probability X. So what are they asking on this question? They're saying at least 2. So just think real life. What does that mean? Somebody says at least 2.
0, 1,
2, 3, 3, 4, 5.
3, 4, 5, 6, 7.
Good. 2, 3, 4, 5, 6, or 7. That's what they want, huh?
Yeah.
Okay.
Yeah.
And what's the opposite of that?
0, 1.
0, yeah, like we have right here. The opposite is 0 or 1, which is less than or equal to 1. That's what you stick in your binom CDF, because that's all the binom CDF can handle. So you put in your binom CDF, number of trials, 7, probability, 0.47, right? And 1. And then you take 1 minus the answer that you get. And that should be right. All right, so let's get it. So binom CDF, 7.471, 1, and 1 minus 0.915.
Yeah.
There it is.
Are you going to do the rest online?
We got a little more time. We good there? That makes sense? All right, so that was a tough one. Yeah, good question. This is now the truth. Now I'm telling the truth. All right, number 12. Let's keep moving. So when purchasing bulk orders of batteries, toy manufacturer, blah, 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 randomly select and test 47 batteries, determine whether each is within specs. The entire shipment, at most 2, do not meet specs. Shipment contains 2% of them do not meet specs. That's a lot of words. What is the probability that this whole shipment will be accepted? That's a lot of words. All right, this will be our last one.
Heart monitor thingy, binom, or
Kinda. Yeah. How do you know it's not exactly like the heart monitor? It's a good question. Yeah, it's tricky. It looks a lot like that one, huh? But it's actually a binom. How do we know that? I know it because we're in the binom section. But how would we know if we...
At least 2.
Yeah, probably those words are good. At most 2. Yeah, at most 2. Yeah. So it's accepted if at most 2 are bad, right? Don't meet specs. At most 2. All right, so that's the question. At most 2. Yeah, we're going to do binom. Now, is it PDF or CDF? How do we know?
this is at least.
Yeah, because the PDF is only for equals, huh?
Yeah.
The CDF is for the greater, well, technically only less than or equal, but we use, so at most 2. So let me encourage you to think exactly like we were just saying. Think real life. What does at most 2 mean? Say it to yourself for a second. Better than, don't say it out loud to yourself. I want everybody to have a chance to think. So think, this is really valuable. These kind of exercises, this will stretch you. Think what at most 2. If somebody said, hey, I was talking to these 7 people for class, and at most 2 of them told me they paid $100 for their calculator. At most 2.
1, 2.
0, 1, 2. We all good there? That's at most 2, isn't it? Okay. So now what is that less than or equal to? That if I said 0, 1, or 2, that's less than or equal to... It couldn't be 3, could it? Because less than or equal to 3 would include 3. It could be equal to 3. If it was 0, 1, 2, 3, it would be less than or equal to 3, huh? So 2 is less than or equal, 0, 1, 2 is less than or equal to 2, isn't it? So that's what you stick in your binom CDF. Now, do we have to do the opposite on this one? No, because we've already got what we're less than or equal to, huh? Does that make sense? So we just put in number of trials, probability, and the number you're less than or equal to. So binom CDF number of trials is what? 47 batteries? I think, right? 47 batteries. And what's the chance each time?
0.02.
Yeah, it's this right here. 2% of them are bad. They don't meet specs. 0.02. And we want to get less than or equal to 2 bad ones. Less than or equal to 2 bad ones. How are we doing? Is that making sense a little bit more about the binom CDF? You always want the number in here. Well, it only takes a number less than or equal to. So how do you remember, when are we going to do the 1 minus? We're not here, huh?
At least.
Well, anytime it's greater, isn't just at least, it could say more. That would mean we got to do 1 minus as well. 1 minus a little different way. Does that make any sense? This function only does lesser things. It only does less. So if in any way it's not less, it's greater, more, at least, all those kind of words, you got to do 1 minus. You got to do the opposite on those. So somebody got an answer on this one? 0.93. Do we? 93. What's that? 9323. Oops, I'm kind of scribbling it out here. 9323. So they want you to change that to percentage. 93.23% of the shipments. And they will reject. What portion will they reject? If that's how much they're going to accept, what portion will they reject? Yeah, 100 minus that, huh? 100 minus 93.23. That's 6.77%. Many will be rejected, right? Oh, no. Almost all will be accepted. There we go. Right? 93% are accepted. All right. Well, we only got to number 12. I had such higher expectations.